Hello and welcome to our lesson on properties of logarithmic functions. This is going to be from section 9.5 in our text. We have three basic rules that we're going to cover, three properties of log functions. I think the first thing I'm going to do is show you how freaking easy it is to learn these and then give you a brief demonstration of how they're useful, like what makes them important. And then we're going to hit some examples from the textbook. Okay, so let's start with first the product rule and how I normally teach this to make it easy to remember. I tell my students that if you're taking the log of a product, now this would be a single term with several factors. If you're taking the log of multiple factors, multiplication turns into addition. And notice that each factor gets its own log. So this is like, I don't know, if you're a couple and you decide to separate, okay? So if you're multiplying and you're in the same log cabin, then you can separate. Each person gets their own log cabin. And the thing to remember is that multiplication turns into addition, or you can say a product turns into a plus. That might be easier to remember. Product plus, they both start with a P. Multiplication makes addition. And before I go to the next rule, the other thing that I do want to illustrate is that these go both ways. So you can take two logs. As long as they have the same base, if they're being added, then you can combine those into a single log, and addition turns into multiplication. So these properties, these rules, they go both ways. Next, the quotient rule says if you have a fraction, it'll turn into subtraction. So again, the numerator and the denominator, they each get separated into their own log cabin, and a fraction makes subtraction. Now again, this goes both ways as well. If you have two logs, as long as they have the same base that are being subtracted, then what you're taking the log of, that'll turn into a fraction, where whichever log comes first is on the top. So there the order is important. It matters who gets to be in the numerator and the denominator. And the last rule, we have the power rule that says if you're taking the log of a term with an exponent, that exponent can come off and it goes down in front. So you could say that the exponent becomes the coefficient of the log. And vice versa. If you're taking the log of, I don't know, something, a variable or a number, and you have a coefficient, you can bring it up and it'll become the exponent. So again, this goes both ways. And now I think I'd like to give just a couple of brief examples that are not in the text to show you how easy these are to work with and why you might want to use them. Let's say, for example, we're taking the log base 2 of 2x. So now 2x is a single term, but it has two factors. And the product rule says if you're taking the log of two factors, you can separate them each into their own log with addition. So this would become log base 2 of 2 plus log base 2 of x. Notice that you do have to keep the same base throughout the problem. And then what makes this nice is that log base 2 of 2 can be simplified. Using the property that we talked about in the previous lesson, we said if the bases match, they cancel, and the exponent is the answer. So log base 2 of 2 would simplify to just 1, and that would allow you to simplify this expression. So there's how it works, and maybe a reason why you would want to do that to get it to simplify. All right, let's look at another example real quick. What if we had log base 3 of A plus log base 3 of B? So again, the product rule says if you have two logs that are separated by addition, as long as they have the same base, you can combine them into a single log and their stuff gets times. But whatever you're taking the log of, those are going to become factors. And that would allow you to simplify that expression as well. So for the quotient rule, real quick, let's say, what if we had log base 3 of x over 3? Taking the log of a fraction here, the quotient rule says that a fraction turns into subtraction, and the numerator and the denominator, they each get their own log. So this would be log base 3 of the top, which is x, minus log base 3 of the bottom. And then notice we've broken off a piece here that can be simplified. So log base 3 of x stays the same, but log base 3 of 3, since the bases match, they cancel, and the exponent is the answer, allows us to simplify. And looking at an example going the other direction, what if we had log base A of 5 minus log base A of 7? Well, here these two logs are separated by subtraction, and the quotient rule says that subtraction turns into a fraction. You can combine the two logs into one. So we're going to have log base A of a fraction, and whoever comes first is on top. So the 5 is on top, and the 7 is on bottom, and we just combine those two terms into a single term. That could be a step of simplification you need to use. And last but not least, the power rule. Let's say we have the natural log of x to the 5th. What the power rule says, it says if you're taking the log of a term with a power, you can bring that exponent down to the front and it'll become the coefficient of your log. And then that might be useful if you're trying to get x by itself. It's a way you can get rid of the exponent. So that's the power rule going this direction. We might also have 3 log base A of x, and we might want to get rid of this coefficient. So going the other way, the power rule says that the coefficient can become the exponent. We can bring that 3 up, and it would become log base A of x to the 3rd. Now you do need to know all three of these properties, and you do need to be able to go both ways, okay? It's good to go both ways. Now there is one other formula I've written here that we're going to cover, and that's b raised to the power of log base b of x is x. And it sort of fits one of the properties I talked about in the previous lesson where I said if the bases match, they cancel. But in this one, what you're taking the log of is the answer. So we will look at an example that illustrates this formula also. Now to the examples in the text, we're going to start with number 6. The instructions say express as the sum of logarithms. So here we can see that we have log base 10. Remember, if there's no base showing, it's understood to be base 10 of a single term with two factors. So this is where the product rule comes into play, because the product rule says that multiplication turns into addition. So we can separate this into log of 0.2 plus log of x, and that is now written as the sum of logarithms. Again, each factor gets its own log, and multiplication turns into addition. A product turns into a plus. Next example, number 22, they ask us to express as a difference of logarithms. So this time we're taking the log of a fraction, and the quotient rule says that a fraction turns into subtraction. So we're going to have two logs now, where the numerator comes first, log of the top. Remember that a fraction makes subtraction. So that's going to be minus log base 3 of w, and that is done, splitting the fraction into subtraction. And next, number 14, the instructions say to express as a product. Now, it may not be apparent, but that means we're going to use the power rule. Here we're taking the log of a term with an exponent, and what we know from the power rule is that the exponent gets to go down on the log. So the exponent is going to become the coefficient. So when the instructions say to express as a product, they're meaning that negative 8 is now multiplied by log base b of q. So that is how to execute the power rule. And our next example, number 26, is going to illustrate how we use the properties of logarithms when there is more than one property to deal with. Here, if you want to know how to read this correctly, this is log base b of x squared y over b to the third. Okay, that's one way you can read it. It could be log base b of x squared y divided by b to the third. The instructions say express in terms of sum and difference of logarithms. The instructions might also say expand completely. So what we want to do is we want to use every property of logarithms that we can possibly use to break this down as much as possible. Now what I notice here, I notice obviously we have a fraction, so that's going to involve the quotient rule. Also, we have exponents, so that'll involve the power rule. But we also have multiplication between the x and the y, and that's going to involve the product rule. So when you've got multiple rules to apply, what you want to do is you want to undo them kind of in the opposite order of the order of operations. Think of it like this. If I want to separate the x and the y, first I need to get them out of the fraction. So the first thing we're going to have to deal with is the fraction, which is the quotient rule, which says we're going to take the log of the numerator. Fraction turns into subtraction, so it's going to be minus log of the denominator. And now that we have the x and the y as their own term, then we can separate the x and the y using the product rule. So then we know that product turns into a plus. That's going to give us log base b of x squared plus log base b of y. Notice the factors get separated into their own log cabins, and a product turns into a plus. And I'm just going to go ahead and bring down this last term for the time being. Okay, so now I want you to notice that we have the x variable isolated, right? We're taking the log of only an x. The y is isolated in his own log cabin, and so is the b to the third. So now that each variable has been separated into their own logs, now if there's any exponents, I can do the power rule. So now we're going to bring the 2 down to the front, and we're going to bring the 3 down to the front. So using the power rule, we're going to get 2 log base b of x plus log base b of y minus 3 log base b of b. And if you were to stop here, you would get partial credit. There is one piece of this expression that can simplify further, and that is the log base b of b. Notice the bases match, and if the bases match, they cancel, and the exponent is the answer. So log base b of b is going to become 1, and then 1 times 3 will give us just a 3 here at the back. The other two terms come down. They cannot be simplified. And that's going to be our final answer in simplest form. Now for the next series of examples, we're going to be looking at combining logarithms. We're going to be using the properties of logarithms to write the expression as a single logarithm. We're compressing, combining the logs into a single log. This problem, we have two logs. They do have to have the same base, and we have addition. So remember, addition is going to turn back into multiplication. So the two logs become 1, and their stuff gets times. That is the product rule, putting the logs back together into a single logarithm. And then we can simplify this one more step by multiplying 75 times 2. Our final answer would be log base a of 150. Next example, number 38. Here we have two natural logs. Remember, natural log is log base e, so these both have a base of e. And we have two logs separated by subtraction. So using the quotient rule, we know that a subtraction turns into a fraction. And the two logs become 1, and their stuff gets f'd up. We're going to fraction it up. And remember, whoever comes first is on top. So then we have the natural log of 54 divided by 6, which we can simplify that one more step. 54 divided by 6 is 9, and we're done. All right, next example, number 41. There is a lot of stuff going on in this problem. And so I'm going to try to explain the order that you attack these properties in when you're combining into a single logarithm. Okay, so the first question I might ask you is, how many terms are there? Well, remember, terms are separated by plus or minus signs. So there's 1, 2, 3 terms, 3 logarithmic terms, and they all three have coefficients. So when we're combining into a single logarithm, any logs that have coefficients, we need to apply the power rule. Each one of these coefficients is going to jump up and become an exponent. So that's going to give us log base a of x to the 1/2 plus log base a of y to the 4th. Notice for the 3, I'm leaving the minus out front. I'm only taking the 3 up as an exponent. That is the safest way to do that. So it's going to remain minus log base a of z cubed. Now that the logs don't have coefficients, we can apply the product and quotient rules. Normally, you're going to work your way from left to right. So the first two logs have addition. They're going to combine into multiplication. So the two logs become 1, and their stuff gets times. And this is where I'm going to take and do something that you can choose to do if you want to. I'm going to convert my rational exponent into a radical symbol. So that's going to become square root of x, y to the 4th. That is multiplication, and the y to the 4th should not be under the radical. Okay, do you understand? You can leave that as x to the 1/2, but x to the 1/2 is the same as square root of x. Either way is fine, but I like to get radical sometimes. So I'm going to leave that square root of x. minus log base a of z to the third. And our next two logarithms are attached with subtraction. That'll turn into a fraction. So that's going to become log base a of whoever comes first is on top. That's going to be square root of x, y to the fourth, all over z to the third. And so there is your answer. And on these problems, you know when to stop when you have only one log. So if I reread the instructions, it says express as a single logarithm and simplify if possible. So again, you know when to stop when there's only one log. Like the movie Highlander, there can be only one log. Next example, number 46. Again, they want us to express this as a single logarithm. We're trying to condense the logs into a single log. And here we do only have two logs, but they're attached with subtraction. That'll turn into a fraction. That's going to be the quotient rule. So remember, the two logs become one, and their stuff gets f'd up. We're going to fraction it up. X cubed minus 8, that's the numerator because he was first, all over x minus 2. And technically that is done because we have only one log, but it is not simplified completely. Okay, so let me show you what you should do next. Notice in the numerator, what we have is the difference of two cubes. X to the third is a cube. 8 is 2 to the third, which is a perfect cube. So since we have the difference of two cubes, we need to factor that. And so that gives me an opportunity to refresh you on factoring sum and difference of cubes. All right, so here we go. In the numerator, to factor the sum or difference of cubes, you're going to start with two sets of parentheses. Notice the second set of parentheses is a little bit wider than the first, and that's because it's going to contain a trinomial. The second step in factoring sum or difference of cubes is to throw in some SOAP. Now, SOAP stands for same, opposite, always positive. SOAP gets you the signs. The first sign is the same as the problem. The next sign has to be opposite of that. And the last sign is always positive. So SOAP gets you the sign for cubes. SOAP is only for cubes and dirty people. And the last step is to fill in the blanks. So remember we said x to the third, that's xxx. To fill in the blanks, we're going to take one of each factor. We're going to take one of the x's, 2 to the third, that's 2 times 2 times 2. We're going to take one of those factors to get the first two blanks. And then for the other three blanks, we're going to square, multiply, square. So we're going to take the first item in the parentheses, we're going to take the x and square it. That's the first blank there. In the middle blank, we're going to multiply x times 2 and ignore the signs. And then in the last blank, we're going to square the 2. 2 squared is 4. And that gets our difference of cubes factored completely. Again, the first two blanks, you take one of each factor, and then you square, multiply, square. Now, in the denominator, we have x minus 2. And now do you see how factoring allows us to simplify further? We can reduce out the common factor. And since the denominator canceled, now we're just going to have log of x squared plus 2x plus 4. You do need to put that in parentheses, otherwise the log would only attach to the x squared. So when there's parentheses used, it means that it's log of all of that stuff, okay? And that is that expression simplified completely. And our last example, number 69, is going to illustrate the last formula that I wrote in the notes. So if you've been wondering, are we ever going to get to this last formula? This is it. Remember, it says if you have a base raised to a power of log with the same base of something, in this case x, whatever you're taking the log of is going to be your answer as long as these bases match. So in our example, we have 3 raised to the power of log base 3 of 4x. The base of the log and the base of the expression are the same, so they'll cancel. And whatever you're taking the log of is your answer. And that is how that particular formula works. And that's done with that problem. And that's the end of this lesson. So, if you have any questions or comments about anything I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.